All right, everyone, welcome back for another deep dive. We always love looking at what's coming up next in space exploration.
Absolutely.
I think we all have that picture in our mind, of the moon, right? The
Yeah.
very classic cratered, just gray
Yeah.
surface.
Very stark.
Yeah, exactly. But what if I told you that there are some spots on the moon that look and are fundamentally completely different
Oh, yeah.
than those typical lunar landscapes, and that they could hold some really amazing secrets about the moon's past,
Mm.
maybe even its future potential?
Yeah.
So today we are taking a deep dive into a mission that's targeting one of these truly unique lunar spots.
Okay.
These are called the Gruithuisen Domes.
Gruithuisen Domes.
Yeah.
Yeah. So what makes these Gruithuisen Domes really interesting is that they kind of go against everything we think about when we picture typical lunar geology.
Okay.
So if you think about it, the common dark plains on the moon are primarily made up of this iron-rich basalt.
Right.
Kind of like if you picture solidified lava flows you might see in Hawaii or
Sure.
something. These domes, however, they appear to be loaded with silica.
Silica.
Yeah, and silica on the moon is a genuine oddity.
Wow.
It's kind of like finding a mountain range that's made entirely of quartz in a landscape that's usually dominated by dark rock. So it just raises so many questions
Yeah.
about the internal history of the moon.
That's fascinating. So who is going to explore these silica-rich domes?
Yeah, well, the team that's heading up to these geological enigmas in 2028, it's a pretty big partnership.
Oh.
We've got Firefly Aerospace,
Okay.
fresh off of their successful Blue Ghost lunar landing.
Yeah.
And they're teaming up with Honeybee Robotics.
Okay.
Now, Honeybee Robotics is part of Blue Origin,
Okay.
and they are building the rover that will essentially be our eyes and instruments on the ground there,
Wow.
exploring these never-before-seen domes.
Okay, so in this deep dive, we're going to talk about, why is this trip to the Gruithuisen Domes so significant?
Yeah.
What is that rover actually going to be doing up there?
Right.
And what are some of the game-changing insights that we might uncover?
Absolutely, and I think it's going to be, pretty amazing what we find.
Yeah, for sure. So let's start by focusing on the Gruithuisen Domes themselves.
Okay, yeah. So as we touched on a little bit earlier, they are volcanic in origin, but it's their suspected high silica content that really sets them apart. Now remember, the vast majority of lunar volcanic activity has produced basalt, which is rich in iron and magnesium.
Right.
So these silica-rich domes really suggest a different kind of magma, a different recipe for lunar volcanism that happened in the moon's ancient past.
Okay.
And here's a detail that I think is just going to spark everyone's imagination.
Okay.
These domes are sitting on the near side of the moon, the face that's always towards us here on Earth.
Right.
And they've never been directly explored.
Never been explored.
Never directly explored.
Wow.
Isn't that amazing?
That's incredible. In a place that we see all the time.
I know.
Literally, we look up and we see the moon and we think we know it so well, and yet there are places that have never been explored.
It really makes the universe feel just a little bigger, doesn't it?
It really does. It really does.
It's amazing to think that in a place that we often, take for granted, there's still these completely untouched geological wonders just waiting to be discovered.
Right. And for anyone who loves those aha moments, I mean, this has got to be right up there. Because
Absolutely.
we are sending a rover to a place that no human has ever explored.
Exactly. It's mind-blowing.
On the moon. That's pretty amazing.
It's a huge deal. And that uniqueness that never been explored before aspect,
Yeah.
it's what makes this upcoming mission so compelling.
So let's talk about the mission itself and who exactly is going to pull this off.
Okay, yeah. So this expedition is targeted for 2028, and it marks Firefly Aerospace's third mission to the moon.
Wow.
And they've designed this really ingenious system for getting everything there.
Okay.
So their Elytra-Dark transfer vehicle acts like a long-haul space truck.
Okay.
It delivers their Blue Ghost lander to the correct orbital neighborhood around the moon. But then that transfer vehicle stays in lunar orbit, and it provides that vital communication back to Earth.
So it's like a relay.
Exactly, a relay in orbit.
Okay.
And then the Blue Ghost lander makes that controlled descent to the surface right near the domes, and it's ready to deploy that Honeybee Robotics rover.
So Blue Ghost is the delivery service.
Yeah, you got it.
And Honeybee is boots on the ground.
Boots on the ground, that's a great way to put it.
And Honeybee Robotics, as we said, isn't a newcomer.
Oh, no, not at all.
It is space.
They're part of Blue Origin's in-space systems.
Right.
And they have an incredible track record.
Yeah, you mentioned that earlier. They've sent over 3,000.
Over 3,000 components and systems into space.
That is a lot.
It's a lot.
Yeah, that's kind of the gold standard when it comes to space hardware.
Yeah, so what are some of the missions that they've contributed to?
Oh, so many.
Yeah.
I mean, just think about Dragonfly.
Okay.
That's that rotorcraft that's heading to Saturn's moon Titan,
Right.
or the Martian moon's exploration mission,
Yeah.
MMX.
Which is bound for Phobos, one of the moons of Mars.
Right.
And they've even contributed to previous lunar missions like Firefly's first Blue Ghost landing and Intuitive Machines' Athena mission.
So they've already got lunar experience.
Yeah, they're not just jumping into this. They're seasoned space veterans.
Right, which is great to know.
Yeah. It adds a lot of confidence to this mission's chances.
For sure. And speaking of Firefly's first Blue Ghost mission,
Yeah.
that wasn't just a quick in and out,
Oh, no.
right?
Not at all.
It touched down in Mare Crisium
That's right.
back in March
Yeah, earlier this year.
of this year, 2025.
Yeah.
And it operated for 14 days,
14 days flawlessly.
which is a record.
Yeah, that's a record-breaking duration for a commercial lunar mission.
That's amazing.
It really is. It highlights Firefly's technical ability, and it makes this upcoming trip to the Gruithuisen Domes just feel a lot more attainable.
Right.
And, they're not stopping there.
Right.
They've got a second lunar mission that's planned for 2026. And this one focuses on operations in lunar orbit and even exploring the far side of the moon.
Wow, so they are committed to the moon.
Yeah, it shows a real commitment to sustained lunar exploration.
That's excellent. So now let's talk about, we've got the lander.
Yeah.
We've got the rover.
Right.
What's that rover going to be doing?
Okay, so the Honeybee rover will be carrying a very sophisticated suite of instruments that are provided by NASA.
Okay.
And they're collectively known as NASA's Lunar Vulcan Imaging and Spectroscopy Explorer.
That's a mouthful.
It is, yeah, Lunar VVasis for short.
Oh, okay, Lunar Venus.
Lunar VS. And essentially think of this as a comprehensive scientific toolkit,
Okay.
specifically designed to investigate the volcanic nature and composition of those intriguing domes.
Right.
And they're particularly focused on the Gruithuisen Gamma Dome,
Oh, okay.
which is one of the most prominent domes in that whole region.
So what's this rover going to be equipped with?
Okay, so there are instruments both on the Blue Ghost lander and on the rover itself.
Okay.
The lander's going to have 2 cameras that are going to document the landing site and track every single move that the rover makes.
Okay.
But the really in-depth analysis comes from the rover's onboard instruments.
Okay.
So it's going to have this infrared multispectral camera system
Okay.
and a spectrometer.
A spectrometer.
Yeah, and that spectrometer is really key because it can basically read the chemical fingerprint of the dome's materials by analyzing different wavelengths of light and particles they emit, even from a distance.
Okay.
So it's like a forensic tool for lunar geology.
It's like lunar CSI.
Exactly, lunar CSI.
I love it.
Yeah.
So what's the rover's itinerary going to look like?
Okay, so the current plan is for the rover to do a traverse along the southern edge of the Gruithuisen Gamma Dome.
Okay.
It's going to have to carefully navigate through a boulder field,
Oh,
which is going to be a good test of its mobility and how well it can handle that terrain.
right.
And then ultimately is going to make its way to the rim of a relatively recent impact crater.
Why an impact crater?
So impact craters are really interesting because they act like natural excavators.
Oh.
They potentially expose these deeper layers of the dome's material, and that gives us an even richer sample of its composition.
Oh, I see.
So we can really get a good look at what's underneath.
So it's not just what's on the surface,
Exactly.
but also what's deeper down.
Deeper down, yeah. And what's really cool is that the rover is scheduled to go back to the lander before lunar sunset.
Okay.
And this isn't just for recharging.
Oh,
It's actually a scientific strategy.
interesting.
It allows for repeat observations of specific boulder targets under different lighting conditions.
Oh,
So just like a photographer might use different light angles to highlight certain textures,
right.
scientists can actually learn more about the surface properties of these boulders by observing them under different illumination.
Wow, that's amazing.
Yeah, it's a really meticulous plan.
It is.
And it shows how much thought has gone into maximizing the scientific return of this mission.
Yeah, it's not just about, getting there and taking a picture and coming back.
Exactly. It's about getting the most data possible.
Yeah, it's about the science.
That's sweet. That's great.
And so, we talked about this lunar vise,
Right.
but you said there are other payloads
Yes, that's right.
on this mission.
So while the rover and the lunar vase instruments are a big part of trying to solve this mystery of the Gruithuisen Domes,
Okay.
there are actually 6 NASA-sponsored scientific payloads total that are going to be on Firefly's Blue Ghost Mission 3.
Wow, okay.
So the big objective is to try to understand the composition and the volcanic processes that formed these unusual domes.
Right.
And that gets back to our initial question about, what does this tell us about the unique geological history of this area?
Right, exactly.
But beyond just that primary goal,
Yeah.
the mission also includes other really valuable scientific investigations and technology demonstrations.
Wow, so it's like a multi-pronged mission.
Exactly. It's a very comprehensive lunar science endeavor.
So let's zoom out a little bit.
Okay. And talk about why this mission is so important in the grand scheme of things.
Right. So if you connect this to the big story of lunar exploration, investigating these Gruithuisen domes could potentially unlock some really valuable insights into the moon's early volcanic activity.
Okay.
It's a chapter in lunar history that we don't know a lot about.
Right.
And if we can confirm that these are silica-rich materials, that could completely change our understanding of how the moon formed and evolved.
Wow.
And on top of that, these domes might hold resources that could be super important for future human missions.
Okay.
We always talk about water ice on the moon,
Right.
but other materials like silica could be equally important for establishing a long-term presence on the moon.
Interesting.
So think about the possibilities for using these materials in construction or even manufacturing on the moon.
Right, yeah, it's all about using local resources.
Yeah, exactly, using what's already there.
It's like living off the land, but on the moon.
It is exactly like living off the land, but on the moon. That's great. So it's not just about looking into the past, but it's also about,
The future.
the future of humans on the moon.
It's about paving the way for a sustained human presence on the moon.
That's awesome. So this mission really signifies a crucial step forward
Yes.
in our understanding of the moon.
Absolutely. And it's about building that foundation
Yeah.
for a human presence there, like you said.
Right. And, we've talked about Firefly and Honeybee and how they're kind of working together.
Right.
This really seems to highlight how, commercial space companies and these companies with this incredible expertise can work together.
Yeah, it's a really powerful trend that we're seeing in space exploration right now.
Yeah.
We're leveraging these established and innovative technologies, and it just
Yeah.
makes achieving these ambitious goals so much more attainable.
Yeah. It's amazing to see how accessible space is becoming.
It really is. It's a testament to how far we've come and how exciting the future of space exploration is.
So to wrap everything up,
Okay.
in 2028, Firefly Aerospace is partnering with Blue Origin's Honeybee Robotics
You got it.
to launch a mission to the Gruithuisen Domes on the moon.
It's going to be an incredible mission.
These domes, as we've talked about, are so unique.
Absolutely.
They're suspected to be rich in silica.
Yeah, which is rare and really scientifically intriguing.
And the Honeybee rover is going to be carrying all sorts of NASA instruments
Yeah, a whole suite of them
to explore these domes.
to explore every nook and cranny.
Yeah, and hopefully unlock those secrets of the moon's geological history and, maybe even identify some valuable resources
Right.
for future missions.
Absolutely.
So as we said before, this is just another example of how exciting lunar exploration is becoming.
Oh, definitely. It's a golden age.
Yeah, it really is. So to leave everyone with something to think about,
Okay, I like it.
beyond those well-known crater
Yeah.
and those familiar gray plains,
Mhm.
what other unexpected geological formations
Ooh.
might be hidden on the moon?
Yeah, just waiting to be discovered.
What stories could they tell us about the history of our solar system?
Right. And think about the implications if we do find large deposits of these rare materials like silica on the moon.
Right. What could we do with those?
Yeah, how would that change our approach to space exploration, to using resources in space?
Right. And even our understanding of how planets form.
It's all connected.
It really is.
It's a new era of lunar discovery unfolding right before our eyes.
So exciting times ahead for lunar exploration.
I can't wait.
I can't wait either. All right, everyone. Thanks for joining us for another deep dive. We'll see you next time.